We're going to go ahead and take a look at number 61 from section 2.4, which deals with graphs of equations. I wanted to spend some time with you on 61 because this was slightly different than problems that you may have seen in the past. And as with anything, when it's new, it's going to pose a new challenge. So the intention of this problem was to get you thinking. If you had a little bit of trouble with it, please go ahead and watch the video. I encourage you to follow along and jot down any observations or any notes that you feel might be helpful for you in the future. So for 61, we are given x times y is equal to 4. And in the problem, what we want to do is we essentially want to graph it. Okay? And from here, they had suggested that you could use your graphing calculator. Use that as kind of a hint that in order to really work with this, let's get this so that to a place where we're more comfortable. Let's get this so that y is on its own. And essentially, in order to do that, what we have to do is we have to divide both sides by x in order to break that multiplication that's happening here. Okay? So one of the first things that I would suggest doing is notice that now you have a rational equation. So you have something that looks like a fraction. So let's talk about restrictions. From here, what are you noticing you cannot have? Or what is the issue with a fraction? What are the restrictions that you have with a fraction? Hopefully some of you are muttering under your breath that you cannot have 0 in the denominator. And to that I say you are absolutely correct. In this case, we're pretty basic here. I can't let x equal 0. Okay? So before we move any further, I'm actually going to go ahead and start setting up some information on a coordinate plane. Okay, x-axis, y-axis. And what I'm going to do is, I know x can't be equal to 0, so I'm actually going to put this dotted line over where x is 0 on the number line. Okay. What I'm essentially doing is, you will find out later on in the semester that this is an asymptote, and it acts like an invisible fence. It's basically a place where your graph shouldn't exist. It's kind of like a black hole in a sense, only in this case it's a orangish yellow line. Nothing can exist in that area. Okay? It's a dead space. So for now, we're going to go ahead and note that. And then it also, the directions in the problem also encouraged you to find any intercepts if you can find them. So if we look at a y-intercept, for example, that's where your x value is 0 and your y value is some number. Well, if we go back into the original problem and we say, okay, great, I'm going to put 0 in for x, that would be a problem, wouldn't it? Because that hits exactly on the restriction that we just identified. So because there's this impossible statement that you have here, and there's no way of getting around it, that means that there are no y-intercepts. So dust ourselves off and let's say, okay, I'll take a look at x-intercepts, which means that our x's are going to take on some value and our y's are guaranteed to be 0. So if we were to go ahead and do that, we'll put 0 in for y and we get 4 over x. And I would suggest going ahead and writing this so that it's a proportion. So then that permits us to do cross multiplication. But this gives us 0 times x, which is 0, and then 1 times 4, which is 4. And again, this gives me a false statement. So because there's a false statement here, that means that there is no x-intercept. So you're probably thinking, okay, well, great. I know what the restrictions are, but I don't have any sort of additional direction, because usually those x and y intercepts give you a vague idea as to which way to go. So what I'm going to say to that is we're going to go ahead and kind of go back to what we've done in the past, and we'll create a table of values. We can plug values in and evaluate. And what I would suggest doing is get really close to x is equal to 0. So, you know, definitely work with -4, -2, but I would also pick -1/2, okay? I would then also pick the positive counterparts of these numbers, and we're just going to go ahead and evaluate this. So to start off, let's work with -4. So we have y is equal to 4 over -4, which becomes -1, so that will go in there. y is equal to 4 over negative 2. That gives us negative 2. Y is equal to 4 over negative 1/2. That looks nasty, but we can basically rewrite this. 4 over negative 1/2 is the same thing as 4 divided by negative 1/2, which means we can skip the first number, flip the second number, and then multiply it. So this becomes negative 8. And we just continue on in that fashion. And so on, and so on. Hopefully you guys find this riveting. But if you don't, it's okay, because I'm done. Okay, so what I have here then in my table are my coordinate points. So if I put my table together, I have negative 4, negative 1, so there's 1 point, negative 2, negative 2, and then 1/2, 8, so that's about there if I eyeball it. So it's gonna connect like so. And then if I were to include the other part, 1/2, 8 would be about here, 2, 2, and then for 1, it's going to go this way. Okay. If you were to use your calculator, you probably see something similar to this. The way that your calculator is, especially if you have like a TI-83, the pixelation will look like there's a solid vertical line that's happening between these two curved lines. That's actually a drawback of the calculator. It's kind of actually putting the asymptote right there in the middle, and you really shouldn't be seeing an asymptote. Again, think of it more along the lines of an invisible fence. So really, I'm going to go ahead and darken this a little bit more. The way that the graph is going to go, it's going to come from negative infinity, and then it's going to loop all the way down to negative infinity along the y-axis. And here, it's going to come up, or it's going to come down. It's going to come back and come down from positive infinity along the y-axis, and then continue to travel to positive infinity along the x-axis. Okay, this is an example of what a rational function looks like when you graph it. It's definitely a little bit different and probably new and potentially scary. But again, as we do more work with it, you will become more comfortable with it. Okay, so keep practicing. I would suggest watching the video a couple times if you need to, or I would also suggest YouTubing graphing rational equations. There might be some good resources out there for you. And if you find any additional ones that you would like to share, by all means, please go ahead and do that. I would greatly appreciate it. Okay, I hope this helped.